Welcome guests to this channel. My name is Kamadafi, a student at Mbara University of Science and Technology. In this video, we shall be talking about nanotechnology, and specifically we shall look at several concepts and we shall deeply scrutinize them and we explain them. So amongst the concepts, we shall look at who coined the term nanotechnology, then we look at what exactly nanotechnology is, and we look at the significance of the nanoscale, then we look at nanoscience and nanotechnologies, if they are new or not new. Then we look at why nanotechnology is important. Then the other bit will be the uses and benefits of nanotechnology. Then we look at the concept of how nanotechnology is used today. Then we look at what businesses are doing to ensure that nanotechnology is safe. Then we look at what businesses then we look at the safety information about nanotechnology. Then we look at the nanotechnology regulation. And regarding nanotechnology regulation, we shall be looking at a question that you may have at the back of your mind, whether the existing laws, or if there is any that exists about nanotechnology. So if these laws and regulations are adequate for managing the nanomaterial safety. So don't go away. Let's get started with who coined the term nanotechnology. So the term nanotechnology was coined in 1974 by a scientist called Norio Tanguy of Tokyo Science University to describe semiconductor processes such as thin film deposition that deal with control on the order of nanometers. His definition still stands as of today. Nanotechnology mainly consisting of processes of separation, consolidation, and deformation of materials by one atom or one molecule. So that was all about who coined the term nanotechnology. Okay, let's go on to see what, or look at what exactly nanotechnology is. And in this bit of the video, we shall be giving the definitions of nanotechnology, several definitions, and several definitions as given by several scholars or scientists. Okay, let's continue. So about nanotechnology, nanotechnology specifically is all about understanding and control of matter at dimensions between approximately 1 and 100 nanometers, where unique phenomena enable novel nanotechnology applications. This definition was given by the US National Nanotechnology Initiative. You may abbreviate it as NNI. So, encompassing nanoscale science, engineering and technology. Nanotechnology involves imaging, measuring, modeling, and manipulating matter at this length scale. And you might be asking yourself about what a nanometer is. And a nanometer is 1 billion. A nanometer is 1 billionth of a meter. And let's take an example whereby a sheet of paper is about 1000 nanometers thick. A single gold atom is about a third of a nanometer in diameter. Dimensions between approximately 1 and 100 nanometers are known as the nanoscale. Unusual physical, chemical, and biological properties can emerge in materials at the nanoscale. So these properties may differ in different ways from the properties of bulk materials and single atoms or molecules. Another definition of nanotechnology that is practical and unconstrained by any arbitrary size limitations says that nanotechnology is the design, characterization, production, and application of structures, devices, and systems by macromolecular scale that produces structures, devices, and systems with at least one superior characteristic or property. Let's now look at the significance of the nanoscale. With nanoscale, we are mainly talking about the measurements in which nanotechnology particles are measured, and that is a nanometer, which is abbreviated as nm. So what is a nanometer? A nanometer is 1000 millionth of a meter. For comparison, a red blood cell is approximately 7000 nanometers wide, and a water molecule is almost 0.3 nanometers across. And of course, you might be interested in the nanoscale, whereby the nanoscale is defined to be from 100 nanometers down to the size of atoms, that is approximately 0.2 nanometers. Why is this so? This is because at this scale, the properties of materials can be very different from those at a large scale. Therefore, what is nanoscience? Nanoscience is defined as the study of phenomena and manipulation of materials at atomic, molecular, and macromolecular scales, where properties differ significantly from those at a larger scale, and technologies as the design, characterization, production, and application of structures, devices, and systems by controlling shape and size at the nanometer scale. Okay, that's all about the significance of the nanoscale. Let's continue and look at nanoscience and nanotechnology. You might have a question at the back of your mind. Is nanotechnology new, or is nanoscience and nanotechnology is new? These two concepts of nanotechnology, nanoscience and the nanotechnologies, are not new. Why? This is because in some cases, nanoscience and nanotechnologies are not new, because chemists have been making polymers, which are large molecules made up of nanoscale subunits, for many decades, and nanotechnologies have been used to create the tiny features on computer chips for the past 20 years. However, advances in the tools that now allow atoms and molecules to be examined and probed with precision have enabled the expansion and development of nanoscience and nanotechnology. Why is nanotechnology important? Nanotechnology improves existing industrial processes, materials, and applications by scaling them down to the nanoscale in order to ultimately fully exploit the unique quantum and surface phenomena that matter exhibits at the nanoscale. And you might be asking about yourself, why nanoscale? Why nanoscale materials and so forth? So we are going to look at nanoscale in detail. And nanoscale specifically, we shall look at the properties of materials that nanoscale materials exhibit. And in this sense, the properties of materials can be different at the nanoscale for main reasons, and they are just two, like this. So first, nanomaterials have a relatively larger surface area when compared to the same mass of cases. Materials that are inert in their larger form. This can make materials more chemically reactive, and in this sense, I mean that in some cases, materials that are inert in their larger form are reactive when produced in their nanoscale form and affect their strength or electrical properties. Secondly, quantum effects can begin to dominate the behavior of matter at the nanoscale, particularly at the lower end, affecting the optical, electrical, and magnetic behavior of materials. These materials can be produced that are nanoscale in one dimension. For example, nanowires, nanorods, and nanotubes. In 2 dimensions, plate like nanocoatings, nanolayers, and graphene, or in 3 dimensions, for example, nanoparticles. So here I mean that nanoscale materials can be produced in 3 dimensions, and in 1 dimension, in 1 dimension, we have, for example, nanowires, nanorods, and nanotubes. Then in 2 dimensions, we have plate-like shapes, for example, nanocoatings, nanolayers, and graphene. Or 3 dimensions, for example, nanoparticles. And all this is due to nanotechnology, and still we find nanotechnology important simply because it improves existing industry processes. And this trend is driven by companies' ongoing quest to improve the existing products. How? By creating smaller components, um, and better performance materials at a lower cost. And a prime example of an industry where nanoscale manufacturing technologies are employed on a large scale and throughout is the semiconductor industry, where device structures have reached the single nanometer scale. For example, your smartphone, your smartwatch or tablet are all containing of billions of transistors on a computer chip the size of a fingernail. Okay, let's look at the uses and benefits of nanotechnology. So, nanotechnology is part of the next wave of innovation in science and engineering that will transform many sectors, including aerospace, energy, information technology, medicine, national defense, and transportation. Nanotechnology will enable the development of next generation materials that are more stronger, that are lighter, and more durable than the materials used today in buildings, bridges, aeroplanes or airplanes, automobiles, and other applications. Nanotechnology also holds great promise for creating products for a more energy efficient world, such as more efficient fuel cells, batteries, and solar panels. Nanotechnology can provide solutions for cleaning contaminated soil and water, and it will play a critical role in the sectors of medicine and healthcare. How? By transforming the medical and healthcare through the design and development of say applications that are used to transform the medicine and health care sectors in general. So healthcare is approaching a revolution, and this has credits to nanotechnology. Here I mean that healthcare is approaching a revolution, and so we thank nanotechnology because highly sophisticated tools for detecting and treating cancer, bandages that prevent infections, enhanced medical imaging, the enhanced disease detection technologies, and more all involvement and have been made possible because of nanotechnology. So the other benefit of nanotechnology is that almost all electronic devices made in the last decades, including today's most advanced computer chips and personal electronic devices, were manufactured using nanotechnology. So we give thanks to nanotechnology. And another use or benefit, sports equipments like baseball bats tennis rackets, motorcycle helmets, and other plastic materials can be and have been made more lighter, stiff, durable, and resilient with nanotechnology. So we continue with another use of nanotechnology, and this is that fabrics that are treated with nanotechnology can resist wrinkling, staining, and bacterial growth, helping clothes stay cleaner and last longer. The other benefit is that thin films found on eyeglasses, computer displays, windows, and other surfaces use nanotechnology, and this is to help them be more water repellent and reflective, resistant or resistant to ultraviolet or infrared light, and fog, scratch resistant, or be more electrically inductive. So the other benefit of nanotechnology is that the performance of many household products like stain removers, antibacterial cleaners, paints, sealants, and air purifiers, and filters can be more enhanced with nanotechnology, and that would be seen as a nice benefit of nanotechnology. The other one is a use, and it says, or it is nanotechnology can help create a cleaner environment. How? Through new water purification methods and by removing pollutants from groundwater and soil. The other benefit is that energy innovations like more efficient solar panels, stronger lightweight wind turbines, lighter carpets, and improved fuel efficiency of cars or mechanical components are all powered by nanotechnology. The other benefit is that personal care products like what? Like more efficient solar panels, stronger like cosmetics and sunscreens can be enhanced with nanotechnology, and food packaging that uses nanotechnology can help detect and prevent spoilage or contamination, helping food stay fresher and longer. The other last but not least benefit of nanotechnology is that some pharmaceutical products have been reformulated with the nano-sized particles to improve their performance. And with due respect, we give credit to nanotechnology, or we say thanks to nanotechnology for all the benefits and uses we have really seen above. So let's go to how nanotechnology is being used today. And in this sense, nanotechnology is already benefiting areas such as healthcare, the environment, energy, and national security.